So, what if your AI didn't just, sit there waiting for your next prompt? Like, what if it actually worked while you slept?
Yeah, I mean, it completely shatters how we measure productivity, honestly. You're no longer just trading your physical time for a result.
Right.
You're basically setting a whole system in motion that just persists entirely without you.
And, well, that persistence is exactly what we're dissecting today. So, okay, let's unpack this.
Let's do it.
For this deep dive, we're looking at a source document. It's titled Les1 OpenClaw, and it essentially details the architecture of an autonomous AI agent called OpenClaw.
Yeah.
And our mission today is to really understand this like monumental shift that's happening in tech right now. We're moving from AI being a reactive tool, like superpowered encyclopedia, to AI being an active autonomous worker.
Exactly. It's a massive leap.
And more importantly, we're going to break down how you, listening to this right now, can actually use this architecture to reclaim your own time.
Because um, we really need to be clear up front here. This isn't just like another app you download to your phone to help you draft emails faster.
Right, totally.
For the last few decades, software has essentially been, well, like a bicycle for the mind. It makes you faster, sure, but you still have to pedal. You have to drive the machine.
Yeah, you're the engine.
Exactly. But OpenClaw represents an entirely different vehicle. It is an autonomous engine. The whole paradigm of work is shifting from interaction to delegation.
And the developer world is just absolutely swarming this engine right now. I mean, the source material outlines this viral explosion that is honestly kind of hard to wrap your head around.
It really is. The numbers are staggering.
Right. Like OpenClaw gained 346,000 GitHub stars in just a few months. It actually beat the 10-year growth curve of React.
Which is wild.
Yeah, React, the foundational framework that powers like massive chunks of the modern internet.
Yeah.
And OpenClaw beat its 10-year curve in a fraction of the time. Jensen Huang, the CEO of NVIDIA, even went on record calling this specific agent architecture the next big wave.
And the user reports coming from inside this ecosystem are just as crazy. People are reporting saving like 5 to 10 hours a week.
10 hours a week?
Yeah, 10 hours is massive. I mean, that is an entire standard workday plus overtime just handed back to you every single week.
Right.
When you look at that kind of velocity beating a 10-year growth curve in mere months, it signifies a massive inflection point. It tells us developers aren't just, testing this out of curiosity. They're actively integrating it into their daily operations because the return on investment is just immediate.
Okay, wait, hold on. Let me play devil's advocate for a second.
Sure.
I hear those numbers, but something just doesn't add up for me.
Mm-hmm.
If this technology is legitimately handing teams an entire day of their week back, and it's growing at this totally unprecedented rate, why isn't my LinkedIn feed absolutely saturated with non-developers talking about it?
That's a great question.
Like, why aren't my friends in HR or marketing or logistics running their entire operations on OpenClaw right now?
Well, that is the crucial bottleneck right there. And the source document actually identifies this exact friction point. We could basically call it the setup fear.
The setup fear. Okay, explain the mechanics of that because, it sounds more psychological than technical.
Oh, it is entirely psychological. Think about it. When a non-technical professional decides they want to, try OpenClaw, they aren't greeted by a friendly, colorful user interface with a big glowing start button.
Right, there's no App Store download.
Exactly. They're confronted with a command line terminal, just that stark black screen with the blinking white cursor, and instantly they're hit with terminology they do not use in their daily lives.
Like what?
Things like API keys, dependencies, environment variables. The fear of that complexity just paralyzes them completely.
So if you're listening to this right now and you're thinking, I don't know how to code. If I touch a terminal, I'm going to accidentally delete my entire hard drive. The source is actually addressing you directly here.
Yes, 100%.
The blocker isn't that you lack the intelligence to use the tool. It's just that a blinking cursor feels incredibly unforgiving.
Precisely. Because a traditional graphical interface, it guides you, right? A terminal, on the other hand, just waits for you to tell it exactly what to do, which kind of implies you need to already know all the answers.
Yeah, which is terrifying if you've never used one.
But the reality of setting up OpenClaw is, it's far less dramatic than it feels. Those intimidating perms are really just digital administrative tasks.
Right.
Like, an API key isn't a complex code. It's literally just a secure digital passport that gives your AI permission to open a specific door, like say your email inbox,
Okay.
and an environment variable that's just the locked drawer where you safely store that passport so it doesn't get stolen.
So we're literally just talking about digital permission slips and file folders here.
Exactly.
And the source explicitly states that getting this running requires zero coding skills. None. You just need like 30 to 45 minutes and the patience to read instructions carefully. But it does warn that mistakes and terminal errors will happen during setup.
They absolutely will, and that is a feature, not a bug.
How so?
Well, terminal errors look terrifying because they usually print out in this bright, angry red text. But an error is really just the computer saying, hey, I couldn't find the passport in the drawer you pointed to.
Oh.
You just redirect it. So to overcome the setup fear, you basically have to stop looking at the terminal as a bomb waiting to go off and start looking at it as, well, a very literal, somewhat stubborn filing clerk.
I love that. Which brings us to how we actually build this thing. And here's where it gets really interesting. To demystify the system, the source breaks OpenClaw down into a 4-part mental model.
Yes.
And it uses an analogy that I just absolutely love. Is that setting up an autonomous agent is exactly like snapping Lego blocks together.
It's the perfect way to think about it.
Right. You don't need to know the chemical composition of the plastic. You don't need to know how to mold the shapes. You just need to understand how 4 specific pre-made pieces logically connect to each other.
And that modularity is the real genius of the architecture here. Simple mental models reduce that awful feeling of overwhelm.
Yeah.
Because when you understand the anatomy of the agent, your whole relationship to the software changes. You stop viewing it as this monolithic, fragile program that you might break, and you start viewing it as a digital employee that you are actively outfitting for a job.
Okay, so let's walk through the mechanics of those 4 Lego blocks. The first block is the body. What exactly constitutes the body of a digital employee?
So the body is the execution environment. It's the physical or virtual space where the agent actually wakes up and runs.
Okay.
If we stick to that employee analogy, the body is the desk and the office space. It holds all the other components together and provides the computing power required to actually operate.
Got it. So you have the office space. Then you snap on the second block, which is the brain.
Yeah.
And this is the underlying artificial intelligence model, right?
Correct.
But we really need to clarify how this differs from the standard chatbots people are used to interacting with. Because when I use a chatbot, the brain is just generating prose. It's writing paragraphs. How does the brain function differently inside OpenClaw?
That is a critical distinction to make. In a chatbot, the LLM, the large language model, is just predicting the next word to talk to you.
Right.
But inside OpenClaw, the brain is doing something called function calling. So instead of generating conversational text, it is generating executable actions.
Oh, interesting.
Yeah, you hand it a problem, and the brain reasons through it. It decides, okay, first I need to open a browser, then I need to extract this data, then I need to format it. It's not just talking to you, it's actively strategizing.
But a brain, like, no matter how good it is at strategizing, can't actually do anything if it doesn't have hands.
Right.
Right? It's just a brain in a jar at that point.
Exactly.
And that is where the third Lego block comes in, the tools.
Yes. The tools are the hands. They are the specific capabilities you give the agent to interact with the outside world. And this is actually where those API keys we talked about come into play.
Oh, right, the digital passports.
Exactly.
Thank you.
You might snap on, say, a web scraping tool, a Google Sheets tool, and maybe a Gmail tool. So the brain says, I need to read the latest financial news. It then uses the web scraping tool to go out, read the web page, and bring that data back.
I really want to highlight why this modular Lego structure is so incredibly powerful for the listener's workflow. Because the body, the brain, and the tools are separate blocks, it means your setup is completely future-proof.
Yes, 100%.
Like if a brand new, insanely advanced AI model drops tomorrow, say the next generation of Claude or GPT, you don't have to rebuild your entire automation from scratch.
No, not at all.
You literally just unsnap the old brain block, snap the new brain block into the body, and your digital employee instantly gets a massive IQ upgrade while keeping all of its tools and permissions perfectly intact.
Exactly. It completely separates the logic from the execution. And that naturally brings us to the fourth and final block, which is honestly the only part the user really interacts with long term.
Right, the instructions.
Yeah.
This is basically the system prompt, right? The job description.
Right. You define the agent's ultimate goal, its constraints, and its general operational rules. And unlike a standard chatbot that just forgets what you were doing the second you close the browser tab, these 4 pieces work in tandem to run continuously.
So you're not constantly reminding it what to do.
No, you write the instructions once, and the system just loops through the work autonomously.
which introduces a pretty massive logistical question.
Okay.
So I have my 4 Lego blocks snapped together. My digital employee has a body, a brain, tools, and instructions. But where does this employee actually sit?
Right.
Because if the body is the execution environment, where does that environment live? The source outlines 2 distinct deployment options, and the choice you make completely dictates whether this thing can actually, work while you sleep.
It is the defining architectural choice of the whole setup. Option 1 is deploying the agent locally, meaning the body lives right on your personal hardware, your MacBook, or your PC.
And the source notes that local deployment gives you maximum privacy, total control, and instantaneous feedback because the data literally never leaves your machine.
Yep, it's very secure.
So if local gives me maximum control over my own systems, why on earth would I ever surrender that control to a third-party server? Why wouldn't I just run my digital employee on the laptop sitting right on my desk?
Because of a very practical, kind of annoying hardware limitation that we call the lid close
The
problem.
lid close problem. Walk us through the mechanics of that.
Just think about the physical reality of a laptop. When you finish your workday, you shut the lid.
Right.
The hardware automatically goes into sleep mode to conserve the battery. The processor throttles down, the hard drive spins down, and the active internet connection is usually severed.
Oh, right.
So if your digital employee's body exists entirely within that laptop's memory, the employee goes into a coma the exact second that lid shuts.
Wow. Okay, so if I built an OpenClaw agent to, say, monitor global competitor pricing across different time zones all night, or to filter a 24-hour news feed while I'm asleep, a local setup completely breaks down.
Totally.
My laptop would have to stay open, awake,
Yeah.
and constantly connected to the internet all night long, which totally defeats the entire purpose of background automation.
Precisely. Local deployment is fantastic for building and testing your Lego blocks, but it is terrible for continuous asynchronous work. To unlock the true potential of an autonomous system, you have to sever its reliance on your personal hardware.
And that leads to option 2.
Right. Option 2, cloud infrastructure. And the source specifically highlights a platform called Agent 37 for this.
So by moving the body of your agent into the cloud onto a dedicated server cluster like Agent 37, you are essentially renting a desk in a digital office building that never ever turns the lights off.
That's a great way to put it.
Your laptop is closed, you are fast asleep, and meanwhile, in some data center somewhere, your OpenClaw agent is actively running reasoning loops, utilizing its tools, and executing your instructions.
It's the ultimate realization of delegating work. However, we really cannot ignore the hidden trap here.
The trap. Let's get into it.
Because a machine that runs continuously, making autonomous decisions while you sleep, sounds super utopian until you realize the mechanical reality of how these models are built.
Yes, the hidden cost problem. Because an agent running in the cloud isn't just using electricity, right? It is constantly consuming API tokens. Can you explain the mechanism of a reasoning loop and how it could potentially drain someone's bank account overnight?
Yeah, we have to look at how an agent actually accomplishes a task. It doesn't just instantly know the answer like magic. It uses a loop of observation, thought, and action.
Okay.
Let's say the agent is trying to navigate a website. First, it uses a vision model to literally look at the screen. It sends that visual data to the brain and asks, what do I click? The brain analyzes the image, identifies a button, and says, click the login button. The agent executes the click. Then it takes another screenshot of the new page, sends it back to the brain, and asks, okay, what now?
And every single one of those back and forth exchanges, like every image analyzed, every instruction generated, cost a tiny fraction of a cent in API usage.
Exactly. And when things go smoothly, those fractions of a cent just add up to mere pennies. It's negligible. But what happens if the agent encounters an unexpected pop-up ad?
Oh, no.
Right. It looks at the screen, doesn't recognize the pop-up, and asks the brain, what is this? The brain guesses incorrectly and says, click the background. The agent clicks, but the pop-up doesn't close. So the agent takes another screenshot, sees the exact same pop-up, and asks the brain again.
Oh, I see. It just gets caught in an infinite loop.
An endless cycle of trying, failing, and requiring the model. And because computers process information at lightning speed, this loop can happen thousands of times in a single hour. If you are using the most advanced, premium, expensive AI model as your agent's brain, you are paying top dollar for every single one of those failed thousands of queries. You can literally wake up to hundreds of dollars in automated API charges for a single stuck task.
That is the exact opposite of reclaiming my peace of mind. I mean, waking up to a $500 bill because my digital employee couldn't figure out how to close a cookie banner is absolutely terrifying.
It is a very real fear.
But the source document provides a really elegant architectural solution to this, right?
Yeah.
Something called 9router.
Yes. 9router is a brilliant piece of engineering. It essentially introduces an intelligent middle layer to your system. Instead of wiring your agent directly to the most expensive premium model, you wire it through 9router first.
It functions almost like a triage nurse in an emergency room.
Okay, yeah.
Like, when you walk into an ER, you don't immediately get sent to the chief of neurosurgery.
Hmm.
The triage nurse evaluates your symptoms. If you just have a minor scrape, they route you to a physician's assistant to get a Band-Aid. They only page the expensive specialist if you have a complex trauma.
Right.
So 9router does the exact same thing with your agent's prompts. It's like an automatic fast checkout line at the grocery store that protects your budget.
That is the perfect mechanism to describe it. 9router uses what's called semantic routing. In milliseconds, it reads the complexity of the agent's request.
Okay.
If the agent just needs to format a date or maybe extract a specific word from a paragraph, 9router instantly recognizes that this is a low-complexity task. So it routes the prompt to a highly efficient, virtually free AI model. It completely bypasses the premium model.
But if the agent is asking for complex logic like, say, synthesizing a 50-page financial report to pull out investment risks, 9router analyzes that vector, recognizes the high cognitive load, and routes it to the premium brain.
Exactly. It dynamically manages the token economics of your system in real time.
That's amazing.
What's fascinating here is that it ensures you are only paying for heavy-duty intelligence when the task actually requires it. It completely protects your budget from infinite loops by throttling costs on mundane actions, which allows you to confidently let the system run while you sleep.
Okay, so let's review where we are. We've conquered the setup fear by understanding the digital paperwork. We've demystified the architecture using our 4 Lego blocks: body, brain, tools, and instructions.
Yep.
We've solved the lid close problem by deploying to the cloud on Agent 37. And we've protected our wallets by putting 9router at the front desk.
Mechanically speaking, the autonomous worker is perfectly optimized at this point.
But there is still one massive friction point left, isn't there? How do I actually talk to this thing every day?
Yes. The interface.
Because if I have to open a command line terminal and write lines of code every single time I want to ask my agent for a status update, I'm never going to use it. The friction of interaction will literally kill the habit.
You've hit on a core truth of software design there. Power is completely meaningless without accessibility.
It's exactly.
Terminals are built for configuration, not for conversation. If checking on your agent feels like programming, you will inevitably abandon it.
Which is why the final piece of the OpenClaw architecture detailed in the source is so vital. It integrates directly into Telegram.
Yes.
You just connect the agent to a standard messaging app.
Yeah.
So instead of dealing with code or navigating complex dashboards, you literally just pull your phone out of your pocket, open Telegram, and send a text message to your agent exactly like you would text a human colleague.
And honestly, the psychology of this interface shift cannot be overstated. By moving the interaction layer to a familiar chat window, the intimidating technology just completely disappears into the background.
It just feels normal.
Exactly. A command line prompt feels like an interrogation, but a text message just feels natural.
Ping becomes Pong. You text your agent like, hey, can you pull the weekly sales numbers and summarize the drop-off in the European market? And a few minutes later, your phone buzzes with the text back containing the exact summary. The interaction is as simple as messaging a friend, but the architecture working asynchronously behind that chat window is vastly powerful.
It beautifully bridges the gap between complex autonomous deployment and human intuition. You're managing a server-grade cloud architecture, utilizing dynamic semantic routing and multi-tool API connections, and you're doing all of it just by sending an emoji on Telegram.
It's incredible. So we really need to zoom out here. We've covered the staggering growth velocity, the modular mental models, the cloud deployment, the token cost routing, and the messaging interfaces. If we synthesize all of this, what is the real core mandate of this OpenClaw document?
I'd say the core mandate is that the era of the prompt is evolving into the era of the process.
The era of the process.
Yeah, we are moving away from synchronous interaction, where the AI only moves when you push it, and we're moving toward asynchronous delegation. Early comprehension of this reusable architecture, it gives you a massive compounding advantage.
And that compounding advantage is the big takeaway for you listening right now. The goal isn't to build a massive, omnipotent AI system by tomorrow afternoon.
No, definitely not.
The goal is just to overcome the initial intimidation. Assemble your first set of Lego blocks. Just build one small agent that does one mundane task.
Exactly. Start small.
Because a system that saves you 1 hour a week today, combined with an agent that saves you 2 hours tomorrow, creates exponential leverage over your time. Step-by-step assembly builds your confidence to manage these systems.
It is fundamentally changing your identity in the workplace. You're going from being a primary producer to being a manager of autonomous producers.
And speaking of managing those digital producers, there is a seemingly small detail near the very end of the source document that actually has massive implications.
Oh, yeah.
The text mentions that once your agent is fully deployed, the final step is defining, quote, your agent's personality and priorities.
Which just cracks open an entirely new, deeply philosophical layer of how work will get done in the future.
Exactly. And I really want to leave you, the listener, with this thought to mull over. In a near future, where everyone has an autonomous agent executing their background work, how much will the specific priorities you program into your digital worker dictate the quality and style of the output?
It's a huge question.
Right. Like, if two different people give their agents the exact same set of logical instructions for a project, but one agent's underlying personality is programmed to be highly risk-averse and meticulously detail-oriented, while the other is programmed to prioritize speed, creativity, and rule-bending, you are going to get two wildly different versions of reality.
You really are.
Even when the machines are doing the heavy lifting, the human intent we program into them will still shape the world we are building. The work equation is no longer just your time for a result. The new equation is your intent, compounded by a machine, working tirelessly while you sleep.